Welcome back to the channel. Hope everybody's doing well. In today's video we're going to be building up a new battery pack for this 2.5 kV insulation tester from Sonel, which is the MIC2510. This is now actually an obsolete tester. It was replaced with the MIC2501, but that actually had less functionality into it, or not the functionalities that I wanted anyway, so I was stuck with this one. More recently they have just come out with the MIC2511, which is much better than this instrument, so I've actually indulged myself and purchased one of those. But I thought, as the battery pack for this, or the replacement battery pack for this, is so expensive, I'd give a go trying to build up a new one to replace this one with and see how we get on. This is the actual battery pack itself. It's an NIMH battery pack. 9.6 volts, 2.4 amp hour. It's made up with individual AA cells. Whilst messing around with this, a pair of pliers on these, I actually found I could have ended up working these out and taking the whole of the battery pack out, and I'm left with the holder there on its own. I did manage to snap off an auxiliary connector off of this end cell here that clips to the side of the holder, so I've made a new one of those up. I'll be able to stick that in place when I've welded it onto the new cell. And in terms of replacement cells, I've got these ones that came from Amazon. They're a Bonide 2800 milliamp hour NIMHL cell, 1.2 volts nominal voltage, of course. And these will slide in very easily into this. Not quite sure how we're going to emulate this plastic casing yet, because I can't do that, but I've got some Captain tape which might well help out. But we can put these all around the right way around. Hopefully they're actually all in series. There we go. So that's the battery pack there. I've cut some new tabs for it. I've got a little tab welder, and we'll start welding on the tabs and see how we get on with it. So I've got my little tab welder here. I've set this up to power level number 3. The strips I've got on 0.15mm in width. However, the weld that you get, or the quality of the weld that you get on these, is very much dependent upon how much pressure you put on these tabs when you weld them. If you put too much on there, you don't get a very good weld. Now, unfortunately, I made a bit of a mess of video recording the tab welding, purely and simply because my hands were in the way all of the time whilst I was doing the welding. I put a few of the spot welds in so you can see what I got up to really, but as you say, my hands are in the way all the time. This unit, it's worth noting that this unit is automatic, so as soon as you place the second probe, the unit registers a circuit and then it fires the weld impulse. For me personally, I'd probably prefer a more manually controlled device, so I can position both the probes as I see fit and then activate the weld impulse, but it is what it is. It has done the job. We got there in the end. To simulate this plastic covering, I've wrapped Captain tape around the new cells. I'm not sure why it needs it really. It does pad out the cells and makes them stick inside this plastic housing so they don't remove, but inside here, the actual battery compartment of the insulation tester itself, it's all insulated in here. You've got the 2 contacts at the end, but that's it, so I don't really know why electrically why you would need to cover it. I think it's purely just mechanical to try and keep it within the actual holder whilst you're removing it, so the battery's staying there. But we'll give it a measure to see how we got on with it. Make sure we have got an actual circuit. Our new pack here, and you can see we're 10.3 volts there. Our old battery pack 6.4. So yeah, it might be recoverable. If I charge it manually, it won't charge whilst it's in the insulation tester, hence going down this route here. This just sits in here and slides in. It is spring loaded, so as you undo these screws it will remove itself from the body of the insulation tester, so it takes a little bit of screwing in. Put that in there. And as long as we've got it up and running, we can do a couple of tests with it just to make sure it's functioning okay. There we go. So the test that will draw the most current from the instrument is the 200 milliamp resistance measurement. We've got it set up to that. We're running it through our Keysight main current mode to measure the peak current coming out. Put the light on him. We're connected to our winding simulator. If we hit the start button, you can see we are 3.02 ohms, which is a bit high, but we're measuring the shunt of the instrument as well as the winding resistance simulator there, and we've measured 216 milliamps, so that is all good. We'll just, the simulator should be 1.17 ohms, so we will just take the meter out of reading and put it back in there, and we'll go again, and we're 1.14 ohms. So that's all good and accurate. Let's go again. 1.12. 1.17, so a little bit of a spread there, but seems to be functioning okay. Should be 0.06 for the leads themselves. Okay, so we've set our instrument to 100 volt range down the bottom there. You see that? And we're connected up to our Time Electronics insulation calibrator. We're set to measure open circuit volts, so we should, unfortunately, we are 109 volts on the instrument. This doesn't have a backlight, and we are 108 volts on our tester, which is good. Next range up, in fact we're doing duals, so let's go 500 volts, and we are 531 on our 532 and 534 on our calibrator. And let's go 2500 volts, switch the range, and we are 2.63 kV and we are 2.60 kV on our calibrator. So that's all good. We'll just do short circuit current, which should be 1 milliamp. Let's do the same ranges again. 1.4 milliamps, which is good. 500 volt range. Yeah, 1.44 again, and finally 2500. We are 1.44 again, so that's all good. Okay, so this is a high range insulation tester anyway, especially on the 2500 volt test setting. We've turned our test setup to 50 giga-ohms. I'll hit the go button and we'll see what reading we get. 48.3, 4, creeping up a little bit. That's still well within specification for that one there. Let's go down a range. Let's go. Let's go 700 mega ohms on there. Still see 694, 695. Yeah, that's good. All well within specs. So yeah, pretty happy. The battery pack hasn't been charged, so We can stick them on charge now we've used a bit up. That's perhaps why it's dropped so quick. And see that it gets a good charge. And hopefully everything is good with our tester again. But that'll be it for this video. Thanks very much for watching. Hope you found it useful, and I'll see you again in the next one.